We have seen about the subatomic particles and the concept of isotopes. That is to be remembered because they will ask questions or you will be required to find the atomic weights and you will be provided with the percentage of different isotopes. So that is to be noted. Isotopes are the systems of the same element with differing number of neutrons or same atomic number and different mass number. Similarly, other two concepts are there. One is called isodiaphates. ISODIAPHERES. Isodiaphates are the species with the same isotopic number. What is meant by isotopic number? So isotopic number is defined as the difference between the mass number and twice the atomic number. So here it is not for same elements. Here we have seen K stands for potassium or kalium. F stands for fluorine. So potassium with mass number potassium isotope, it is called potassium isotope 39. Fluorine isotope 19. Because mass number will be roughly twice the atomic number. Mass number will be roughly twice the atomic number. If atomic number is 9, mass number of fluorine should be 18. But there is one more isotope of fluorine called fluorine 19. So at present we see that there are two types of isotopes for fluorine. Fluorine 18 and fluorine 19. Similarly, potassium atomic number is 19 means twice is 38. Normal isotope of potassium is potassium 38. Heavier isotope of potassium is potassium 39. So potassium 39 is the heavier isotope of potassium. Fluorine 19 is the heavier isotope of fluorine. There is one other isotope with the mass number 38. But for both the systems, atomic number will not differ. So if a system contains this value is same, that is mass number minus twice the atomic number. For example, these two species, potassium 39 isotope and fluorine 19 isotopes are called isodiaphates because the difference. So mass number of potassium is 39 in this isotope minus twice atomic number of potassium is 90. For any isotope, atomic number will not change. But for different isotope, mass number will be changed. That is to be noted. So 39 minus 38 is 1. Here the isotopic number is 1. So here also you see this system F19 isotope whose atomic number is always 9. So 19 minus 2 into 9. 2 into 9 is 18. 19 minus 18 is also 1. So here the isotopic number is same for both the species. Isotopic number is 1 for potassium 39 as well as fluorine 19. So these are called isodiaphates. So isodiaphates are the systems which follow this law, same isotopic number, where isotopic number is defined as the difference between the mass number and twice the atomic number. Lastly, next important concept called isoteres. ISOTERES. Isoteres are the systems or species with species can be different elements. Species with same number of atoms and same number of electrons. Same number of atoms and same number of electrons. Let us consider these two. These are called isoteres. Nitrogen molecule and carbon molecule. So far we have seen about the atomic species. Now we come across a species called molecule. Molecule is a collective unit. So subatomic particle, number of subatomic particles give rise to atoms, number of atoms give rise to molecules. Now you see two types of molecules, nitrogen and carbon monoxide. So nitrogen symbol is N. Nitrogen atom is represented as capital N, whereas capital C represents carbon, capital O represents oxygen, capital CO represents carbon monoxide. But if you write capital C small o, that represents a different element called cobalt. So here you have to be careful about writing. So capital C and capital O means carbon monoxide. So nitrogen, there are two nitrogen atoms, N2. There are two nitrogen atoms. So number of atoms is 2. Carbon monoxide, one carbon atom and one oxygen atom. Total number of atoms is 2. So So it may contain different atoms, but total number of atoms is 2. That is to be noted. Nitrogen atomic number 7. Nitrogen molecule is N2. Nitrogen atomic number is 7. Means that it contains 7 electrons. So one nitrogen atom contains 7 electrons. Another nitrogen atom contains 7 electrons. Total number of electrons is 14 for nitrogen 2 species. Here carbon atomic number is 6. Means that it contains 6 electrons. Oxygen atomic number is 8. Means that it contains 8 electrons. Total number of electrons is 14. So total number of electrons is 14 for both the species. The number of atoms is 2 for both the species. These two species have same number of atoms and same number of electrons. Such systems are called isoteres. So isodiaphates and isoteres. Isotones are the systems with the same number of neutrons. Systems with the same number of neutrons. So these are to be noted. So different concepts: isotopes, isobars, isotones, isodiaphates and isoteres. The important ones are the isotopes. Isotopes. So presence of isotopes. So chlorine. If you have chlorine, there are two types of isotopes: chlorine 35 and chlorine 37. So atomic mass number is 35, but atomic weight is 35.45 because the percentage is different. X percentage of chlorine 35, Y percentage of chlorine 37. So X into 35 plus Y into 37 total divided by X plus Y gives atomic weight, that is 35.45. So 35.45 comes to be in this range. So chlorine consists of two types of isotopes. So let us confine our concept only to isotopes, because sums will be asked. Will be given percentages of this chlorine 35 and chlorine 37, and you will be required to find the atomic weight of this one. Means that X percentage of 35, Y percentage of 37, total number sum of the percentages is 100. So X into 35 plus Y into 37 divided by X. If X and Y are given, you can calculate, or if it is given and X is given, you can calculate the percentage of Y. Similarly is the case carbon C13 we will refer. C12, normally carbon atomic number is 6, means that 6 protons or 6 electrons. Twice is C12. Normal isotope is C12. C13 is a heavier isotope. So Cl37 is the heavier isotope. F19 is the heavier isotope. K39 is the heavier isotope. H2, H3, H1, protium, deuterium, tritium. So these are the different isotopes. So these are the concepts of presence of isotopes is the reason for the atomic weight, that is to be noted. So this with respect to the different species with the same number of different parameters designated as isotopes, isobars, etc. Now we will see the atomic arrangement. We have seen that the atom is composed of 3 important subatomic particles. Central region is nucleus, composed of protons and neutrons, surrounding which electrons are there. Already we have seen that protons are positively charged, electrons are negatively charged. Generally we see that, we know that these like charges repel each other, unlike charges attract each other. Means that, let us take the case of helium. Helium means helium nucleus will contain 2 protons. It may contain some number of neutrons, but outside you have 2 electrons. You have 2 electrons. Both the electrons are negatively charged. Both the electrons are negatively charged. So they will repel one another. But in spite of the repulsive forces, they have to be in position. They cannot escape because it contains only 2 electrons. 2 electrons have to be there. How the arrangement? So that is given by different. So initially there are different models. Thomson model, Rutherford model and Bohr's model. These are the 3 important models. So very initial thing we have seen that Dalton, who described atom is indivisible. Later on it was observed that the atom is divisible. So Thomson model, here he considered an atom as the cloud of positive charge in which electrons are embedded. Cloud of positive charge. Cloud means a continuous material. So you can see the clouds, but you cannot catch the clouds. They have some mass. The mass is so negligible, so it has to be taken in a cage-like arrangement. So that is the thing. So he described atom as a cloud of positive charge. Cloud of positive charge into which negative charges are embedded. So it is the model is called Plum pudding model. Plum pudding model means plum. You have a plum fruit. So plum fruit or any pudding is made up of plum fruits. Pudding is a continuous mass into which plum fruits, plum cake is. You see the plum cake. Cake is a continuous material where the plum is inserted or different fruits are inserted. Here also pudding is a continuous material. It is of positive charge into which negative charges are embedded. So this is his description. Later on it was observed that electrons are not embedded. Electrons form a separate region. Rutherford model. He described electrons revolve around the nucleus in certain orbits. He told that they revolve in the circular orbits. He modified the Bohr, modified that they revolve in elliptic orbits. So one another model, they revolve in elliptic orbits. In these cases also each has one another model is de Broglie arrangement. Electron is so far electron is considered as the particle. De Broglie introduced a concept of wave. Electrons are considered as waves. Electrons are considered as waves means they have to be in motion. So each scientist described certain model which is well established by certain experiments. It is not just a practice of notebook or something else. That is to be noted. We will see them in details, limitations of each model, advantages of each model. The most accepted model is de Broglie, that you will see in due course. Once again you will see the comparative accounts of different models and how the electrons are arranged in an atom is given by what is called electronic configuration. Lastly, we will see this in detail. Electronic configuration is the arrangement of electrons in the atom outside the nucleus. Carbon contains 6 electrons. Each electron is negatively charged. 6 negative charges will repel one another. They have to be properly positioned. Nitrogen, so like that. So if you have heavier elements, lead 82, atomic number is 82 means 82 electrons are outside the nucleus. 82, all the electrons are negatively charged, but they cannot be in a plum pudding model. That is to be, so the most accepted model is de Broglie wave. So we can see the comparative account and salient features of different models of atom in elements so as to arrive at the electronic configuration. Now we are in the process of defining different models. The initial model is that Thomson's model, which proposed atom to be a pudding of positive charge or cloud of positive charge into which negative charges are embedded. But this model could not explain most of the systems. That is why later on it was modified by Rutherford. So Rutherford's model, it is called. The pioneering experiment for this Rutherford model is alpha ray scattering using gold foils. Means that he bombarded helium nucleus. Helium nucleus. Helium atomic number is 2, mass number is 4, means that it contains 2 protons and 2 neutrons and 2 electrons. The 2 electrons are removed, means that protons and neutrons. 2 protons and 2 neutrons. Protons are positively charged, neutrons are chargeless, so it is only nucleus. It is called helium nucleus. Helium nucleus is nothing but alpha rays. Alpha rays are helium nucleus. So he bombarded thin gold foils. Gold foils. So gold sheet, gold ingot, right? Gold is precious metal. Thin sheet of or thin strip is called foil. Smallest gold foil. So this he bombarded with alpha rays. Some of the rays were deflected. Some of the rays are not deflected. So many of the rays are not deflected. Only few of the rays are deflected. Means that by this method he studied that he is bombarding with positive charge. Here atom, if it contains positive charge, the positive charge will be repelling. Positive charge will be repelling. Bombarded with positive charge or alpha rays are positively charged material. If the alpha rays are deflected, that region is positive. If the alpha rays are continuously traveling, that is made up of negative charge because opposite charges attract each other. So in certain regions, alpha rays pierced into the gold foils. In certain region, alpha rays were deflected. So the deflected rays you was able to collect using applied positive charge, negative charge, etc. so forth. So based on this deflection, he came to the conclusion that it is valid conclusion that atom is composed of only positively charged central region called nucleus. Because here you have electron is negative charge, alpha rays are positive charge, opposite charges will attract each other, it will go undeflected. So some regions it is going undeflected, some regions it is deflected. So the deflected region is only small, that is called nucleus. So central region is nucleus. So based on this he proposed a model that atom, the subatomic particles, protons and neutrons are situated at the center of the atom, surrounding which electrons revolve in certain orbits, he told. Certain orbits, that is the arrangement of Rutherford model. So failures of Rutherford model, it could not explain heavy atoms. Most of the systems cannot be explained by Rutherford model. It could not explain why if the electrons revolve, anything if it revolves means at one stage it will revolve, revolution, running, etc. It is only working. If work is done, it loses its energy content. If it loses the energy content, so electrons revolve, they cannot be continuously revolving. If they revolve, they tend to lose their energy. At last, they should fall into the nucleus. That is the general accepted pattern. It is not circular orbit. This is called circular orbit. The circular orbit is getting go on. The circular radius is getting go on reduced. This is called spiral. So it is not strictly a circular geometry. Circular geometry means it is not continuously in a circular orbit. As time proceeds, it comes to the nucleus because electron is negatively charged. Nucleus is positively charged. It is attracted towards the nucleus. So when it is attracted, so it is equivalent to rope pulling on either side. Rope pulling along with rotation. Rope pulling along with the rotation. It has to be rotating and also it is subjected to the action of nucleus, which is oppositely charged. In this way, it should come to the nucleus. At one stage, it should fall into the nucleus. But it is not the actual case. Electrons are not falling into the nucleus. These are not explained by Rutherford model. So these aspects are overcome by Bohr's model. He proposed electron as a wave. He proposed the electron as a wave. Wave means wave. So wave nature and particle nature. There are two types. Even in physics, I would have studied about the two. Wave nature of light, particle nature of light. So the smallest particle we tell proton. But in the case of smallest particle of light energy is called photon. That is to be noted. Smallest particle of sound energy is called phonon. That is why it is called phone. Phone means sound. Photon means light. So photon is the smallest constituent of light energy. Whereas phonon is the smallest constituent of sound energy. But they do not carry mass. They do not carry mass. Proton has mass. Proton. Proton has mass. So there are some systems which possess energy but not mass. Heat energy. But heat energy does not possess mass. You can heat water sample. If you hot water, cold water, water is having definite weight. So we don't assign weight to the heat. So heat energy, light energy, sound energy, the smallest energy values are represented as photons and phonons. They do not carry mass. They pass through different systems. How it is possible? He explained by wave nature. So the wave nature of light is established by a physical phenomenon called diffraction. So diffraction is the bending of light around the obstacle. He has a light source and there is an obstacle. So he observed that the light source part was observed behind the obstacle. Obstacle is a material which will not transmit light, but he could see the thing. It is possible only when light has bent through the obstacle. This bending phenomenon is called diffraction. Diffraction cannot be explained by rectilinear propagation of light. Diffraction is possible only if light travels in the form of waves. Similarly is the case with sound. Sound also supposed to travel in the form of waves. So the best effects of light and sound in real life is for thunder and lightning. So charges, when they collide, the colliding effect is reflected as light. Light travels faster. That is why lightning first. Then sound travels slow. Light velocity is 3 into 10 power 8 meter per second. Sound velocity is only 330 meter per second. 330 less than a kilometer per second. 330 meter per second. That is 3 lakhs kilometer per second. So that is why thunder effect is later and lightning effect is faster. So here they are made up of only charges. The collision of charges has produced light, has produced sound. It has come across the medium, sky medium. So they travel in the form of waves. So the wave electrons are proceeding in the form of waves. He proposed that electrons are not stable. They are revolving in the form of waves. So normal revolution means in this pattern. In this pattern. Whereas revolution along with vibration, this is called wave. So if you take the case of only top. Top is stable only in the spinning position. If you whip the top with the spinning, it will be revolving. When its revolution action is lost, it will fall. It will fall. So top is stable in the spinning position. Also, electrons would be stable only in the spinning position. Then only they can revolve. If they are not spinning, they have to lose their electron, come to the nucleus. It is not actually taking place. Electrons are not coming and falling into the nucleus, which indicates that their movement is only with a certain wave motion or circular motion. So in this wave motion, whenever you have a wave, these waves are of two types: transverse waves and longitudinal waves. Transverse waves and longitudinal waves. Transverse, so waves is represented in this fashion. So the maximum, this is displacement. Y-axis is displacement, x-axis is direction. So here you have to note that the waves propagate as well as vibrate. So propagation and vibration, they are different. Propagation. So propagation means moving in one direction. Vibration means oscillation in either direction. If you take the case of string, tightly bound string. Tightly bound string, if you give a small tap to the tightly bound string, it will be oscillating in this fashion. It will be oscillating. Or if you throw a stone into the river, waves will be developed in the circular fashion. Waves will be developed in the circular fashion. So these are called two types of. So y-axis is displacement, x-axis is the propagation. There are two: vibration, propagation. Direction of propagation, direction of vibration are perpendicular to one another. So both are light waves and sound waves. Light waves are transverse waves. Sound waves are longitudinal waves. Both are called electromagnetic waves or electromagnetic radiation. Now you have to see the salient aspects which you have studied about the electromagnetic radiation. So electromagnetic radiation, as the name implies, it consists of two components, electric component, magnetic component. And it movement is of two types, vibration and propagation. Direction of vibration and propagation. So vibrate in one direction, propagate in another direction. Vibrate along this is called vibration. This is called propagation. So direction of vibration and direction of propagation are perpendicular to one another. Electrical field is perpendicular to magnetic field. The wave direction is perpendicular to both electrical and magnetic field. So electromagnetic radiation is composed of these three: electrical component, magnetic component. It has direction of vibration, direction of propagation. So whenever you assign anything, so it is associated with the three important parameters called wavelength, frequency and velocity. So it is called C equal to nu lambda or V equal to n lambda. V equal to n lambda. C or V is called velocity. N or nu is called frequency. So this is called frequency. F or E, Q U, E N, C Y. This one is called wavelength. So wavelength as the name implies, length of one particular wave. What is meant by length of one? This is general wave. This portion is called one wave. This portion is called another wave. So it is now made up of number of waves. So this is called one wave. How many waves are there in cross a point in unit time? That is called frequency. So frequency is the reciprocal of time. Even in normal terms, frequency of a bus, we tell. Frequency of a bus, how many buses cross a particular point in 1 hour. How many waves cross a particular point in 1 second. It is the unit of smaller unit of time, that's all. So frequency is the reciprocal of time, number of waves crossing per. So and their product is called wavelength. So wavelength unit is meter and frequency is second inverse. Meter, second inverse, their product is meter per second, that is nothing but velocity. So velocity is the product of wavelength and frequency. Here also, electron is considered as a wave, electron wave. Electron revolve in certain waves. If it is revolving in waves, what is its wavelength? Is given by lambda equal to h by p or h by mv. This is important relation you might have studied to be noted. De Broglie wavelength. He assigned wave nature to the particle nature. Wave nature to the particle. So particles will be spending their energy only in the form of waves. That is only possible. Electrons are stable only in the spinning position. That is wave motion. Here h is called Planck's constant. H is called Planck's constant. M is called mass of the particle, electron. V is called velocity of the particle. So if a particle of mass m moves with the velocity of v, its wave length is given by lambda equal to h by mv. That is to be noted. So he correlated. So here m is also there. M means rectilinear motion. Velocity, rectilinear motion. H, angular motion. So two types of motion, linear motion and angular motion. So motion of a spring in one direction, but motion of a circular plate, revolutions per wheels. So the motion is called circular motion. So that is to be noted. So angular velocity, linear velocity. Angular velocity means number of angle described in unit time. Angle is denoted by theta. Theta by t, time taken, is called angular velocity. It is denoted as omega. V is called distance by time. Both are velocities. V is distance by time. Angular velocity omega is angle by time. So angle unit is given by radians. Angle unit is given by radians. So in maths you might have studied about this important relation, pi radians equal to 180 degree. Even in your calculator etc. this degree, radiant, gradient, angular measures are there. So electron, so nucleus, electron if it is in this position, angle differs. That is to be noted. Whenever it is revolution, the electron revolves in certain orbits, its angular position varies. So these are the models accepted by de Broglie. So de Broglie wave model is the most accepted model for the atom where the electrons revolve in elliptic orbits. Once again, this Bohr and de Broglie, how they are assigned are best explained by electronic configuration of atoms that we will see in due course. At present, the most accepted model is de Broglie and Bohr model, which describes atom as composed of positively charged nucleus at the center into which electrons revolve in certain elliptic orbits. The number of orbits may differ. They are called energy levels. What is meant by energy level, etc. that can be covered in the aspect of electronic configuration.